Hey guys, welcome to day 6 of the CSES problem set. Skipped a few days, but we're back into it. As I said in the first video, CSES problem set is not like an everyday thing. It's just to supplement my learning for code forces. Obviously, the idea is to basically try to be able to simplify code forces problems into a problem in this collection of practice problems, right? So yeah, a lot of these introductory problems have felt kind of ad hoc, but they're always a good like mental workout. Like they all take me quite a little bit. So yeah, without further being said, let's just jump straight into it. I'm stumbling over my words today. Oh, okay. Given two coin piles containing A and B coins, on each move you can either remove one coin from the left pile, or 2 coins from the right pile, or 2 coins from the left pile and 1 coin from the right pile. Your task is to efficiently find out if you can empty both piles. Okay. Coin piles. The first input is t number of test cases, so t equals into input. And then after this there are t lines where we take an A and B, so for underscore in range A and B, or for A in range T, A comma B equals map int input split, and then for each test print yes if you can empty the piles and no otherwise. Okay, so we're given two operations: remove 1 from left and 2 from right, or 2 from left and 1 from right. So 2 from, wait, remove 1, remove 1 coin from the left and 2 coins from the right, or 2 coins from the left and 1 coin from the, okay, so 2, okay, this one's impossible, and this one is, okay, it looks like brute force to me right now. Like I can't really think of a, maybe there's a math answer, right? So it's 3, so we can basically simplify everything down to like certain cases, right? 2, 1, 1, 2, 2, 2. Like everything can be simplified down to one of these 3 cases. The question is how we decide to simplify it. Because it's just yes, yes, no. And then given something like 6, 4, what would we do? We would do this 2, 1. So 4, 3. And then 2, 2. So that would be no. But if we swapped it and did 3, 1. That would also be a no, because then we'd be left with 1, 0. So yeah, I guess there's this case 1, 0 like this. But 3, 3 works, so you have to greedily choose. Like, if A is larger, you do this. If B is larger, you do this. And then check the case at the end between like one of these 4 cases. But then it's just brute force. So yeah, I mean, let's just brute force it then. Fuck it. What's my constraints? Be 10 to the 9. If A is greater than B. Okay, so for while, okay, we should define results as O, let's use tuples, results will not be modified, O1, 1, O, O1, 1, O, and then 2, 1, 1, 2. Then while A, B, not in results if A is greater than B, then A minus equals 2, B minus equals 1, else is greater than or equal to, because it doesn't matter. Else we swap these around. And then if A, B is equal to AB in else print no. So this is my, I just write out the gate brute force implementation. Seems to pass. Check one test case 6, 4. Expected output should be no. Yeah. Now the question is there any edge cases? 6, 6, 4, 5, 3, 3. It's 1, 2. Then we print yes. And then there's also case, oh, like infinite loops, so we gotta take those into account. Where it's like 10, 1. We do 8, 0. And then we do 6, -2, which is no good. Let's check 10, 1. One test case should be no. This just runs forever, right? So basically, if A equals 0 or B equals 0, then print no and break. And print no and continue. Print no. Wait. Flag equals false. Set flag equals true. Print no break. If not flag. Okay. Seems like it handles everything. Programming, CSES, coin piles. TLE. That should have been expected. Jesus. Third one was accepted. Where are we slow? So, okay, here. Basically, you're telling me there's a math answer. That is what I'm getting out of this. The real question is, how can we... How can we make this faster? Well, I am brute force simulating it, but so what are our operations? These are our operations, which means what does this mean? If it ever ends up as... Okay, wait, let's see. 11. So no's. Yes, this is a no. Okay, well every operation removes 3 coins, which means our total coins, so A plus B, needs to be A plus 3 mod A plus B mod 3 equals 0. And then this reminds me of a quant question. Let me see if I can find that video.
Dino Dingus.
Turtle flips, no average salary, cooking cereal. Last ball, yes, this one. It reminds me of this
This is Gringo.
video, where basically the idea is each round remove 2 balls. If balls are same color, add back A. If balls are different colors, add back a pink. And will the last ball be blue or pink? And the idea behind this problem was you have to realize some things, and what you have to realize is yeah, you have 3 possible options, and then what are the chances? What are the what do you get back for each one? Let me see. Okay. Yeah, the total change. Calculate the total change. Alright, here it is. So, blue minus 1, and then red minus 2. This kind of reminds me of this problem a little bit, where it's like, okay, what we need to realize here is A plus B mod 3 must equal to 0, and then the bigger number can't be 2 times more than the lesser number, because we subtract 2, subtract 1, because if it is, then we'll get a fail case, right? So, like for example, this one will get to 0 when this one still has values. Case here, these are the same, so this works. Let's pick this case here. This passes, but this doesn't pass the first case where it's mod 3. So let's find a different. Let's do like 10 and 4, and we'll see how this fails. Because we have to greedily pick the big one, so, and we can only pick 4 times, so up to 8, so it gets to 2 and 0. Right, and this is a fail case. So, yeah, our realizations here are that mod 3 equals 0. I guess it wasn't really like this ball problem, but it made me think of this problem. And I think we can get the answer here. It's A plus B mod 3 is equal to 0, and then A, it's max A, B, two times min A, B. It's not equal to, it's it's like this. Max A and B is less than or equal to 2 times min A and B. So if not this, we print no. If not this, we print no. Else, we print yes. I think that's it. So go here, remove all this. Basically, you check if A plus B mod 3 is equal to 0. We print no. Else, or elif max A B if max A and B is greater than 2 times min A B, print no. Else, print yes. Okay, that's no yes. Okay. There we go. Submit. Browse. Compiles. And there we go. We got it. This question wasn't that bad. There's a realization question. This question was probably slightly harder than... I don't even need this line here. This question was probably slightly harder than Hello 26A. That question took me 30 minutes to do. And it was like another realization problem. What was it called? It was Alice and Bob. Let's see if I can find it. Problems. Oh, nope. Hello 2026. Binary array game. Yes. Another realization problem. The trick to this one was to realize the edges. Took me about 30 minutes. This one took me about 20 minutes. And the realization was slightly harder, I think. Was it? This is roughly the same. I would say they're roughly the same difficulty. Okay, let's do another. Palindrome reorder. Given a string, your task is to reorder its letters in such a way that it becomes a palindrome. A palindrome. Palindrome. I always say palindrome. It reads the same forwards and backwards. Input. The only input line has a string of length n consisting of characters A to Z. Output, print a palindrome consisting of the characters of the original string. You may print any valid solution. If there are no solutions, print no solution. Okay, so given this output, A C A B A C A. Okay, that it becomes a palindrome. Okay, this is very simple. This feels like a LeetCode problem. So first things first, I would from collections import counter. For those of y'all that watched my Code Forces Everyday until GM video today, you know that I really like counter now. This data structure is just so useful. And then n equals counter input. And so now we basically check. Okay, well, it's pretty valid to have the string itself as well, so we can do operations on it. And then we can have count equals counter in. And we'll see if I need to do this or not, or if it's simple, I should do this or not. If not, then I'll put it back. But so if n is odd, then if n is odd, then it needs a central digit. If n is even, then it doesn't. So case if n, let's do it if n is even. I feel like that's easier. If n is even, then everything in counter needs to be able to mod 2 equals 0. Right. Yes. If n is odd, then everything except one thing in counter needs to be able to mod 2 equals 0. So I feel like we can just put this back. So it feels like it's just a for loop for key in counter. Okay, well, I guess not. We can check. Oh, what? If, oh, didn't mean to do that. N equals input, and then counter equals counter in, and then for, okay, if in mod 2 equals 0, else, okay, for key in counter, we can do this. Center equals in mod 2 for key in counter, if counter key mod 2 equals 0, oh, that's good. If it does not equal to 0, center minus equals 1. If center is less than 0, break. Print no break. Print no exit. Print yes. Oh, we have to print no solution. Else, we can track a to print equals empty string. Else, we can build to print in here. Python. Insert. Okay. Let's use a list here. And then we to print dot append counter key divided by 2, and then dot insert 0 counter key divided by 2. This is a number, so we do key times. So if I'm envisioning this correctly, they should give, like, say if the key was A, and then A here is 1, 2, 3, 4, 5, 6, then it should do 3 A's in the front, 3 A's in the back. Now I'm trying to figure out if it's, so then it needs to be the center. So we need a, so everything is split perfectly for us. So this is our array, this is our blocks. There's always an even number of blocks until we get here. We just stick it straight in the center. So it's to print dot insert len to print divided by 2. So this is len 4 divided by 2 is 2. So 0, 1, 2. And then we do key times counter key. And then we print star. No, we print dot join to print Jover. And mod 2 center equals len in mod 2 Jover. Then we'll divide for string and int counter key divided by 2. Counter. Okay. This is a string. We should do this. This worked. Right, this is a palindrome. Yeah, with the center. And then let's test one where it's AA, BB, B, C, 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 B, B. No solution. Good. And then let's test AAA, BBB, or BB, CC. Good. Let's do AAAA, BB, CC, CC, D, 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 D. D, D, CC. Okay, yeah. Yeah, it looks like it's working. Submit it. There we go. Got it. Well, we didn't look at the analysis for the last question. Let's look at that after this one. Count C denote the number of times the letter C appears in the string. That's what we did. Create a palindrome if it's odd for at most 1. To create the palindrome, we first go from A to Z and add count. Then if some letters on, we add it as a center. Yes. Finally, we go to Z to A. Yeah, I mean, that's basically what we did. We just did some weird inserting, which I'm pretty sure is O to the n time. What is the time complexity of this? It's like, we're key in counter, and then we insert. Insert is ON. Huh. It's ON squared. So, low-key, to make this faster, what we can do is we can not append. We can instead of inserting, we can do this. Okay, hold on. Let me figure out how to make this faster. So if this, then we do this. instead of putting it at the end, we should insert 0. So we should do this. This is O to the 1 time. This, and then, okay. Well, let's save the code that works. Which is we didn't have this line. Okay. And then we could keep, let's just comment all of this out. So for key encounter, if this, then we insert 0, else we do this anyway, and we center minus equals 1, and then we to print dot append key, and then we can keep this part, and then at the end we can do okay, we can track a flag. False. Set centered equals to true here, and then if centered print else, print this plus to print revert sorted to print reversed true. Wait. Oh, it's let me think. Join. This reverses it. We start at 1. Oh, that didn't work. It should be close though. C A. Why is it empty string? Where am I getting empty string? The print is empty. Centered equals false. Centered for key in it's then okay, where is this coming from? Here. B is 1, so we're inserting one divided by 2 is 0. If this greater than 0. Okay. Fixed. Okay. I think this is fixed. Check. There should be O of N now. Let me check. Okay, never mind. I don't think I changed anything because this. Okay. So instead of inserting, what we can do is append. Append is O of 1. So instead of inserting, we can just append. Yes, this still works. But now this gets rid of the O of N operation. Okay. Double check this. It's yeah, this is bugging because we get the first part correct and then be in the center, and then we need to reverse everything. So if we do, okay, let's just leave that as is. Let's play around with it. Print to print from 1 to the end. What does this give us? C. Let's grab this string actually. BBC. Wow. Why did we? AA, BB, C. Okay. Something's not right about this. It's BBBC. It's BBC. Then this doesn't work. Appending to. Because if we append. Okay, well, to make this way simpler, if we can just. Instead of having a centered key, a centered bool, center letter, and then set center letter equal to key, and then we can just do remove all of this. Plus center letter plus reversed to print. Okay, that seems to work now. Yes, this is O of n time. Yes, we got it all in. Let's submit it. Yes. Fastest. Results. Code time. Okay, it was relatively. It's the same code time. Didn't make it faster at all. Wow. Okay. What time is it? 57. Let's look over the analysis for coin piles, and then we'll call it a day. Since each move removes 3 coins, the total number. Okay, we got that. Each move removes at least 1 coin from each pile, so the number of coins in a pile must be at most twice. Okay, we got that. We can always greedily, when the pile has more, the same number we can arbitrarily choose. Yeah, that's what we did. Why'd they make this so complicated? But okay. Well, we did 2 problems. That's a good thing. Um, if y'all enjoyed this video, be sure to like and subscribe. We'll be doing more CSES problems sometime in the future. And yeah, go check out today's Code Forces Everyday video, and like and subscribe. I'll see you guys next time. Bye.